Good morning, afternoon, or evening to you all, and welcome. Pavel and I are here to walk you through IP Fabric, our automated network assurance platform. Once we've introduced ourselves properly, we'll delve into exactly what that means and how it works. My name is Darren Fulwell. I'm product evangelist for IP Fabric. I've been in the networking field for around 25 years and have worked as a network engineer, consultant, and architect for a variety of customers and resellers. I've built, supported, managed, and maintained networks for businesses in a whole range of different verticals, from public sector through financial institutions to retail and manufacturing companies. I like to think I've seen most things in my career, but as with anything else in networking, the only thing I'm really sure is what I don't yet know. So like most, I'm a lifelong learner. And in recent times, that's meant a trend towards network automation, as I guess it is for most of us. Through my personal associations with Cisco, I helped start an initiative called Init6 to mentor and guide network engineers through the shift in network operations. And we work closely with the network community to take fellow engineers on that journey with us. For me personally, that's developed into a desire to use automation techniques to improve service availability. I suppose some might call that network reliability engineering. My goal with it has been to understand how to build that integrated operational ecosystem with the primary goal of maximizing service uptime. Enter IP Fabric. Earlier in 2020, I had the very good fortune to be introduced to Pavel and the team. And after seeing just what the platform was capable of, all the time and energy and heartache that it could have saved me over the years, managing and assessing those customer networks, I really started to appreciate the advantages that it could bring in providing a foundation for that automated operational ecosystem. And so I jumped in with both feet. Hopefully today we can give you a bit of a flavor as to just why I made that move. Pavel.
Thanks, Darren. Hi, I'm Pavel Bykov, co-founder and CEO of IP Fabric, and I fell in love with networking not long before my CCNA certification in the year 2000, after which I've been lucky enough to jump right away into practice by being on the team building the largest IP call center at the time, and from there on building continuously larger projects, culminating in building and managing dozens of global and Fortune 500 networks. At the same time, I've been heavily involved with network theory, both data plane and the control plane point of view. And first, I got intimate with the data plane by developing and instructing QoS courses for all kinds of platforms, from software through 2940, Cisco satellite family, 2960 to 3750, the Sasquatch family, 4500 Galaxy, the beloved 6500 Crossbar, PFC, DFC, but also including bus from SUP1 to SUP2T, GSRs, provider platforms like ES20+, CRS, and all the way to Nexus and ASR 9K, and validating practical implications of those the platform design, this design decision by running various load tests through Spirent, Ixia, running proof of concept before implementing these technologies at large scale in practice. At the same time, I've also been interested in the control plane, both practically by implementing multinational IPv6 deployments, architecting mergers and acquisitions, digital transformations, and also theoretically by developing and instructing courses from multicast to MPLS VPN to being CCIE instructor. And throughout my career, I've been fortunate to meet thousands of network professionals, and it was obvious that we're all speaking in the same concepts, using the same language, and we see the network in the same way and also experience the same problems. There were two things that struck me the most. The first, that each vendor wanted us to adopt their worldview, creating a layer between us as engineers and the technology itself. The routing table is same everywhere. There are same rules for best prefix match, same next hops, same route policies, and even for forwarding, same queuing and prioritization logic. And differences, there are differences, but largely they are superficial. Even when we're looking at specific protocols like OSPF, and there is same auto-reference bandwidth, same cost, same SPF algorithm as per standard. So why is it so hard to display a BGP table when switching vendors? when it doesn't materially change the outcome. And the second thing that struck me was the disparity between architecting the network and then engineering and operating the network. What happens after that celebration when a project is completed? What happens when you need to do a change? And how often does the network change? If something breaks, was it ever working before? So to answer these questions, I've been doing scripting since the early days, from Bash, Expect, Perl, PHP, Python, whatever was in fashion. And the scripting is great when the final result provides the insight. But most of the time is spent overcoming boring issues with parsing, error handling, version compatibility, or vendor support. And furthermore, scripts have to be maintained. So spending more and more time on scripting and less on doing actual networking and getting the required insight is not what I wanted to do. And so if we are all thinking the same thing as network professionals and are looking for the same thing, why don't we have the tools to help us become better network professionals and the data scientists that we really are? So this was the premise for starting IP Fabric.
Thanks, Pavel. So the problem, it's safe to say that every modern business depends on its IT, obviously, and the network provides the underpinning to all the systems on which we rely. Business needs IT to just be permanently available to support process with minimal operational overhead. But it's obvious to anyone in IT just how big a stretch that is due to many factors, not least complexity. We often hear talk of how the latest technology or product can simplify our IT and our networks, but we do need to face the fact that complexity is often necessary. To provide the facilities business needs, we have to manage and maintain multiple networks in an organization, and most importantly, the interactions between them. Most organizations still rely on at least one or more LAN environments, one or more DCs, a WAN, be it software-defined or traditional, and of course, more and more are getting access to public cloud. With that complexity comes the spectre of technical debt. In a recent blog post, Terry Slattery described technical debt as the accumulation of aging devices, old operating systems, unnecessary or partial configs, and variances in deployment. He's a lot more poetic than I am, but you can relate to exactly what he's saying, because that sounds like every network that I've ever touched. How many times have you heard about that dreaded, nearly complete migration project or merger or acquisition that's never completely rationalized the systems and applications? Through the lifetime of any network, time and project pressures on implementation teams invariably lead to cut corners in project delivery, resulting in that dreaded incomplete documentation. We all know how much network engineers love to document their work. And of course, we get gaps in monitoring and support cover at handover to the support teams as a result. There are manual operational processes which have a requirement to harvest network information before progress can be made. Everything from troubleshooting incident tickets to validating support contracts. And then, of course, we have the more recent challenges of regulatory compliance that require regular wholesale audits, followed by remediation programs of changes to the environment to put controls in place. But that's okay, because network automation is going to solve all that, right? Well, of course, not quite. While centrally managing those and automatically delivering those changes and testing for the success or otherwise can save time and help standardize network config, the plethora of different control mechanisms for the multiple network domains raises the questions of coordination of effort, of team collaboration across silos, and a shared operational view of network information. Network programmability using Python and Ansible, even automation platforms like NSO, might help execute changes in a more standardized and efficient way, but with their device-centric view, they only go so far. So, what about intent-based networking? This ability to take business intent for the network and translate it to technical capabilities that can be rendered in configuration across different network domains. Verify that the state of the network correctly reflects that intent, and then provides a feedback mechanism to fix configuration should it drift. Can that save us? Sounds like magic, right? but it's not quite there yet. When it matures, the approach will certainly enable us to respond to the business requirements in an agile and standardized way. But in the here and now, we're going to have to create orchestration workflows to translate that intent and render it across the myriad of network control planes. And how do you know what to automate if you don't know in a normalized way how networks are configured, how they're operating, and importantly, interoperating right now across vendors, across platforms, and across operational silos? The first thing you need is visibility into the configuration and state of the individual devices in your network, and then the insight that brings through an understanding of the behavior of the network as a whole. And this is where IP Fabric steps in. Originally conceived as the first steps towards a true intent-based networking platform, IP Fabric has developed into the ultimate central reference source of all network data in our customers' IT environments. The system is built along similar lines to a data warehouse. If you remember your Database 101 class, there are 3 phases to population of a database system. Number 1, extract the data from the set of disparate sources. Number 2, transform that data, taking it and rewriting it into a normalized form. And then 3, the load of that data into the database itself so it's available to be queried. Compare and contrast that with the 3 phases of data acquisition for IP Fabric. The first is discovery, where IP Fabric extracts configuration and state data from the CLIs and the APIs for a range of different vendor platforms, both on-prem and cloud-based. Then the analysis phase takes that data and transforms it at a device level into a normalized vendor-neutral form. It then creates a network-level model of the relationships and the interactions between devices and domains, and stores them in a multi-model database, tracking not just the physical connections between devices, but the relationships between them at higher layers up the stack. Information is stored in its most appropriate form, whether that's graph, key value store, or JSON data, which you can then access via a web UI, providing an interactive search capability with dynamic visualization, effectively replacing that static documentation.
Okay, can I interrupt?
Of course you can.
Aaron, by the way, welcome to the Network Field Day.
Thank you.
I joined many times before, and it's really great to see you guys here. By the way, I know Pavel and Darren from the community as well. So Darren is the CCD. When I see him joining the IP Fabric, really, I thought, yeah, these guys are, they know what they are doing. So it's really cool to see. What I want to say here, I follow, by the way, the IP Fabric almost from day one. I have been following what IP Fabric is doing. And it was just maybe a couple vendors, but now it's good to see there are many vendors supported by the platform. Can you a little bit talk about that and multi-vendor support, especially?
Sure. I mean, the vendor count goes up regularly. I mean, Pavel will be able to tell you more of the detail of the history, but yeah, we've got a selection shown here. We have grown beyond that list. Even with every single release that we're developing, the point is that because we have the model, it's all about how we parse the outputs in order to get data from the individual devices and the individual operating systems into the model. The model is flexible enough to be able to extract information from pretty much any CLI or API. API being a relatively recent introduction, we're able to bring Meraki and various others in now through the dashboards. Pavel, is there anything you want to add?
Yeah, so there is definitely, because it's a matrix complexity, it's not only about adding a specific vendor, it's also about adding the specific technology for that specific vendor. We are going down the path of really closely partnering with our customers to define what would be our next steps and progressing in a reasonable fashion, because it would be unreasonable to say that we are going to support everything or push this requirement down to the user. When we were even thinking of, we can offload some of this work to the user. Really, what our thought process with this is that it's not only about bringing value to the user and not, forcing them to develop their own part of the solution, but it's also about how this information fits into the overall network model. So while it's flexible enough for us to control, so far it's not. We want to maintain this plug and play ability of the platform. That what it can do, it does, and if it can be extended, it can be extended through integrations. But overall, the support for the technologies and protocols is being added by us. That said, we have definitely expanded greatly over the past months, adding things from pseudowires. We've added MPLS some time ago, adding multicast, which I will be happy to show you. And generally, the technologies that were historically giving network professionals a hard time to operate because of their overall complexity. So right now we are preparing a security release where we will focus on the security aspects of like advanced concepts of Palo Alto and Checkpoint and so on. This is one of the primary development streams that we do in the company. So we have separate development for network technologies and network model, and the actual full stack software development, where we have people dedicated to developing this vendor and technology support.
So a question for you, Pavel. How open is the interface between IP Fabric and the various devices? So if there's something that you're not supporting, can somebody on the street just jump in and get the information however they need to?
No, so this is what we are so far keeping to ourselves. It's everything is running through the API, but this extensibility, we intend to publish everything through the network model. So you're able to not really look for a specific text, but for a specific meaning and specific intent of the technology operation.
Yeah,
so
I think that's a really important point.
So while it is definitely possible for us to add this possibility that you can just collect anything, and there are things like that in the works, because this is indeed something that's being asked quite often. The intent is how we move, the question is how we move from template-based approach of the configuration template, where you have to know specific syntax of the specific vendor, of the specific family, of the specific operating system, to actually saying that I want my technology to operate in this way, regardless of what the vendor syntax looks like. And because we are pushing into this direction of intent, thus the collection of just text is secondary for us. But indeed, this is something that's being worked on.
Yeah, all I was going to say there was Jody, that the point with the modeling at the back end is that we're looking at the relationships between devices and at multi-layer. So this isn't just about being able to take config and parse it on a device level. It's being able to understand those relationships. So it's quite a complex gathering and analysis piece that we have to do. Now, you mentioned about people being able to come to us with perhaps new devices or new vendors. We regularly take that sort of query from a customer. They've found a pocket of a certain vendor of a certain platform in their network. Can we do anything with that? Well, what we do is we simply raise tasks into our development team to go ahead and implement that as part of the process. We release code versions every 6 weeks or so, or 6 to 8 weeks, and typically we look to address that ability of bringing in new platforms as quickly as we can in that way. Simply by gathering the appropriate data, we can extract the right commands that we need in order then to map that into our model. So.
And Darren, I have a question for you.
Sure.
You guys started out with talking about intent-based, and that's a buzzword we're hearing from a lot of a lot today. Everyone's intent-based, and kind of what you're doing with the discovery. That's a very crowded space as well. You know, and I don't want to mention the other companies doing it because this is your spot. What I'm going to be looking for, and maybe you're going to get to this, what differentiates you?
Sure.
What makes you unique? So that's what I'm going to be looking for. So I really want you to make a point of, you know, whether it's now or later on, what makes you special in this spot?
We hope we'll be able to give you an indication.
I think once we get to the demo, this is where we can show it off, because you know PowerPoint can handle quite a bit. So, really looking forward to demonstrate to you practically what the platform can do.
Great.
And, how it
Thank you.
Works. Thanks, Bob. So the web UI is actually underpinned with a comprehensive REST API, which not only provides the capabilities that you see through the UI, but also is able to be used to allow integration into wider operational tooling. And I guess, Rita, this sings a little to what you're saying, because one of the areas we find in IP Fabric is, while the platform itself is very much self-contained, we do expose all the data within the platform to be able to be integrated very, very easily with the wider ecosystem. So hopefully that'll play into answering some of your question there. Ultimately, what we're after doing here is democratizing access to that deep network data. The network engineer will have access to all of the data that they always did, but it's going to be in one place. It's going to be accessible, it's going to be searchable and visual, without having to trawl through the network, without having to collate and make manual, possibly error-prone associations, and without having to refer to their out-of-date documentation. The network architect will have full visibility of the current state of the network at a point in time, where they can use to plan changes and build migration plans and rollouts. The network automation engineer will have access to up-to-date inventory, configuration, and state data with which to make those config decisions without having to write their own routines to fetch it from the network devices. The network manager has accurate data which can be summarized for reporting and compliance purposes, inventory information for support contracts, code version information for software upgrade planning, and so on. The project manager has evidence that the project they're delivering is meeting its success criteria and delivering a compliant infrastructure. They'll also have the ability to indicate progress of rollouts or mitigation projects through dashboards. And the security team have visibility of how security will be deployed in their network. They can verify the effectiveness of firewall rules, both in terms of how they impact intended traffic flows and even whether they're being hit or not. And the application team have access to information about VLANs and IP addressing for their services, and also the ability to simulate access to their applications from any point in the network. The beauty of the approach is that this is the same data, so it's totally consistent. There are no silos, no waiting for information from other teams, and most importantly for the network team, no updating documentation. And as the data is available through web UI or API, it can be made accessible to any operational process, whether that's integration with CMDBs and monitoring platforms, whether that's programmatically for custom tool sets, or whether that's through querying an event notification through a chat system, all driving us a little bit closer to that nirvana of cross-domain, cross-vendor intent-based networking. So,
hey, Darren, this is Tony. I have a question.
Tony.
Good. Glad to talk to you
Good to
today.
see you, mate. Good to see you.
You mentioned the application teams will be able to test access to their applications. Are you guys sending synthetic traffic, or are you just evaluating routing and firewall rules?
Yeah, so basically, we're able to use the forwarding and the, as you say, the policy that's stored in the model in order to simulate that end-to-end path. So Pavel will show you that in the demonstration.
Yep. So no synthetic traffic, because again, tracking this traffic for us, our biggest advantage here is the understanding of how all of the technologies interrelate and are interdependent on each other. So then we are able to run simulations extremely quickly and get to the results, and without actually running the synthetic traffic.
Thanks.
So I have a question for you guys, and this is, I guess, more abstract. I see networks and the interrelation of services becoming even more complex than we've ever seen before.
Yes.
We see overlays upon overlays upon overlays.
Yes.
We see intersection points between different domains that now behave very differently than what we've seen before. And so I think this model, this thing that you're doing has always kind of been the panacea, but I think it's gotten like 100 times harder than what it was, maybe even just 5 years ago. So I'm kind of curious. I mean, do you guys agree with that thought process, and how are you guys handling that complexity with so much virtualization and so much abstraction that's going on in the networks today? How is that changing the way you approach modeling networks? Because even something like an application and application behavior gets a lot more difficult when you talk about multiple VPNs or multiple places for security, or something like SASE, where the security stack isn't.
This is definitely a very interesting question, and a very good one at that, because the actual resulting complexity is only the perceived complexity, because when it's a virtual network inside some VXLANs, inside some other virtualized network, it's over the routing, over some underlay, and then for every single question, if you try to find an answer, it really becomes exponentially complex. However, from systems point of view, VXLANs like tunneling, there is a clear dependency in the OSI model. So programmatically, what things like the concepts, they do not change. They are still we are still operating about 100 protocols and technologies in the network is what we are seeing. So we do definitely need to keep pace with the technologies that are coming out. However, we find the network model to be very resilient, in a sense that if it's routing, there are certain rules how the routing operates, and it doesn't matter if it's on a higher level or on a lower level. And then creating those layers internally, we are able to achieve this by frankly having a multimodal database that is able to have a graph model where we can actually express everything in graph math. At the same time, the key value and the JSON docs essentially to create both the device model and the overall network model, and just interconnect everything with the layers. So by having layers, we are addressing the internal complexity of the solution the same way how the real network addresses that.
All right, so I'll hold reservation on how you visualize that until we actually see the demo. I think that's also one of the challenges, right?
Sure. So
this data is available to me. So you guys could go a long way in making this a lot easier if you're able to visualize overlays and things like that. So I might be coming back to this question later. I guess is what I'm saying.
Oh yeah. Definitely a big part of the demo as well. I mean, the visual part is this is exactly also what I felt as a network engineer, that essentially we are trying to get from point A to point B. Ant colony optimization. It's always extremely much easier to visualize what we want to do in networks than it is to interpret it in data form. Of course, depending on what we are trying to achieve, but from path point of view, it's just like your navigation on your phone. You don't want the step-by-step directions on turn west on the 131st Street, but you want to see where you're going and what are the what's the situation around you. In the same way, for the networks, this visualization part is, I feel, is a very critical component to these technologies.